Hi guys, welcome to lesson 4.2, patterns and linear functions. So our objective for today is that I can identify and represent patterns that describe linear functions. So we have a long list of vocabulary words, so let's just dive in. Independent variable is the variable you are controlling. That's the variable you are changing. The dependent variable changes in response to the independent. So one way of remembering this is that the dependent variable depends on the independent. All right, our input is the independent variable. This is going to go on our x-axis. This is true in math. This is true in science. Your independent variable will go on your x-axis. Your dependent variable will always go on your y-axis, and that is the output.
Yanela Gomez, please come to the office. Yanela Gomez, please come to the office.
Okay. A function is a relationship that pairs each input with exactly one output. Exactly one output. Each input goes to exactly one place. And that it passes the vertical line test, which we will come up with, or we will talk about in about 5 or 6 lessons. All right. Linear functions is a function whose graph is a straight, non-vertical line. Another way of saying that is that it has a constant rate of change.
Where have you heard that before?
Hopefully 7th grade.
Your essential understanding. The value of one variable may be uniquely determined by the value of another variable. Such relationships may be represented using tables, words, equations, ordered pairs, and graphs.
Okay, lots of fun stuff there. So, problem number 1, representing a geometric relationship. In the diagram, what is the relationship between the number of triangles and the perimeter of the figure they form? Represent this relationship using a table, words, an equation, and a graph. That should be an equation, not and equation. All right, so let's take a look at it. The perimeter of one triangle is going to be 10. The perimeter of 2 triangles together is going to be 14. Perimeter of 3 triangles together is going to be 18. And the perimeter of 4 triangles together is 22. So we can make a rough sketch, and this doesn't have to be a perfect graph.
Thank goodness you didn't leave us enough room.
Yeah. All right, so what do good graphs need? They need to have labels, and they need to have a scale. So
and they need to have space to do them neatly. Okay.
Just wait until you get to the practice B and half your graph is cut off.
Never mind.
All right, so make sure that your graph is as neat as you can. In this space, on any test or a quiz, I will be giving you much more space than this. So in the bottom, we have on our x-axis the triangle number. On our y-axis is the perimeter. And you can see Mrs. Irzo plotted those 4 points, and it forms what looks like a straight line to me. All right, so we also wanted to list it as a table. So we can say our triangle number, and we can say the perimeter. When we make a table, you'll put your x value on the left column and your y value on the right. So we've got 1, 2, 3, 4, 10, 14, 18, 22. So that's another way of representing those 3. Third way is to write the equation, which is 4x plus 6. So we are adding with each new triangle, we add 1 base, which is that 4. But the 3's are still the same. There's always 2 sides of the shape that have a length of 3. So 3 plus 3 is 6, and we are adding 4 every time. 4 times x plus 6. And if you'll notice in the table, when we look at our rate of change is going up by 4 every single time. All right, lastly, we were asked to put it into words. So we can say that a triangle has a perimeter of 10. Each additional triangle increases this perimeter by 4. So, question B is, if you know the perimeter of n triangles, some number, how do you find the perimeter of n plus 1 triangles? Well, we would just add 4 because each next step adds 4 to our perimeter. Letter C, how do your answers to part B relate to the equation in part A? Well, by adding 4 every single time, that is our rate of change.
And since the rate of change is constant all the way through, that's how we get our linear equation.
All right. Problem, there's an example for you guys to try on your own. So we want this to be represented in a couple different ways for that figure there. I only did a table on mine. All right, so x and y. X is going to be our figure number. All right, x is our figure number. Y is the number of squares in that figure. So with the first figure, we have 5 total squares. Well, we can list, we got 3 figures there. So the first one, we've got 5. 1, 2, 3, 4, 5. In our second one, we have 9. And in our third one, we have 13. Very nice.
Thank you.
So what are we increasing by each time? We are increasing by 4. And what did we start with when x is 0? So if we took away the pattern, if we worked one step backwards and we took away each of the arms, all we're going to have is one lonely little square in the middle there. So 4x plus 1. Okay. Do we want to make a graph?
It will be linear.
It will be linear. All right, moving on. Problem number 2. We want to find out, is the relationship a linear function? So to do this, we look at what's called the first difference. So we are just going to find the difference between each of our spaces on our table. So we're on the input side, we're adding 1 for each line. For our output side, we're adding 2 to each line. Now, does that represent, is that constant? Are we adding the same thing each and every time? Yes, we are. So that is linear. Yes. Letter B, does the set of ordered pairs 0, 2, 1, 4, 3, 5, and 1, 8 represent a linear function? Explain your reasoning.
I always have to write these in a table. So we have our input and our output.
All right, so let's remember, if it is a function, it has to have exactly one output for each input. So 1 goes to 4 and 1 goes to 8. That is not exactly one output for that input. Our function machine is broken, so that is not a linear function. It's not linear and it's not a function. All right. Next page, I want you guys to give it a try. Identify, is it linear or nonlinear? So problem number 1, Table shows the amount of water in a tank after X minutes being drained. Is the relationship a function? Is it linear? Well, first of all, does each of our inputs go to exactly one output? Yes, they do. There's nothing that, there's no inputs being repeated, so we're good there. So now we need to figure out if it's linear. So we're going to look for that first difference. So 0 to 1 is +1, 1 to 2 +1, 2 to 3 +1. On the y side, we are subtracting 12 from each move, so that is linear. All right, letter B. Let's put those numbers into a table. We've got 2, 4, 3, 7, 4, 10, and 5, 13. All right, so do we have any inputs that are being repeated? No, we don't. So we look to see what is our first difference. So on our input side, we are adding 1 to each side. On our output side, we are adding 3, and adding 3. So that is a linear function. All right, so bottom of the page, rate your level of understanding of this lesson, 1 to 4. Write down any questions you may have, and do make sure that you fill out your summary. And we will see you all in class. And my class, do me a favor, check the wall of shame for papers that you may have turned in without names. All right, see ya.